Hello everyone, this is Hoda Ganji. In this video, I'm going to show you how we can use Loft to create a surface in Dynamo in Revit. So I'm going to work on a surface like this. This is a chapel, and I want to show you how we can create this chapel using Loft in Dynamo. So I'm going to open a new project. I prefer to go with default metric template. Before opening Dynamo, I want to change the units to be on meters, 3 decimal places, and I want to go to Dynamo. Let's open a new project. So if you go to Geometry under Surfaces and under Surface, there is an option to create surfaces by Loft. So this is what I'm gonna use, right? And as you see, it uses some cross sections, and when I hover the mouse around it, it says curves, right? So I can use curves to create cross sections, and those cross sections will give me a surface, right? So in order to create some curves, you can go to curves here, and maybe what I'm interested in is this nerves curve. I want to go with by points and maybe degrees, this one. Okay, so let's see the image again. So let's say maybe we're going to start from here. Let's assume we have like 8 to 10 meters here and about like 6 meters here. So I want to bring a point. So the first point is going to be somewhere around 8 meters in the Z direction. You can also use number sliders. So that's our first point. The second point is on the ground, so Z is 0, but it's gonna move on the X direction for about like 6 meters. So that goes to the X. Next point, it goes up again. So I'm gonna copy this point here. And the amount of movement in the X direction is double the amount that we had here. So it's gonna be A times 2, which means whatever parameter we have over there, we're gonna double it, and then we're gonna assign it to X. Then the next one here, so it's on the ground again, and this time the X is A times 3, so 1, 2, 3. I want to go with a code block, or you can use multiplication. So that value that we had, that goes to X here. And finally, the last point is still 8 meters higher, but this time the width is 8 times 4. You got the idea. So this goes here, this goes here. These points will create a curve for me, but in order to be able to connect all these points to one point, I need a list. Whenever you are dealing with more than one item in Dynamo, you can use a list. So I'll go with list create. I'm gonna connect the point. The order matters. First one to item 0, second one to item 1, and so on. And this goes to point. Right? Now let me show you something about the degree here. If you put the degree on 1, it's gonna be straight lines. If you put it on 0, there would be no curve at all, right? If you go with 2, it's gonna be like this. 3 is gonna be like this. I'll prefer to go with maybe 2 here. So for now, I'm gonna keep going. Later we can adjust the Z so it's not gonna go below the ground or something. But for now, this should be good, right? So I want to create 3 curves, right? What I have here is basically my first curve. So I can keep this code block to the left because I want to use them again. But these items here, I want to group them, and I want to name it curve 1. So this is my first cross section, and actually I'm going to create 3 cross sections, and then I would need a list to connect my 3 cross sections together. So next I want to create the second cross section here. So let's say maybe we have another point, and if from here to here it was 6 meters, I want to move this point in the green axis, the y direction, I want to move it by 6 meters. So I want to assign that 6 that we had, I want to assign it to the y. So now the point is over there. I also want to move it up to get close to there, but you see it's not moving by 8 meters but maybe half of that. So I want to assign a value to z, and I want it to be half the height that I assigned before. So I want to go with a divided by 2, or maybe I can go with h divided by 2. So whatever value was there, which was 8, that goes here, is going to be my h, that goes to z. Right now the second point is going to be to the right side by the unit that we had, which is 6 meters. So I want to create a new point. I want to move it in the x direction by 6 meters. The reason I'm using the same code block is that if I change this number later, the whole thing is going to be updated accordingly. So this goes to my x, and the height is going to be 8 meters. So h goes to my z. Okay, and actually I also need to assign 6 meters to the y, so this goes here. So I created the second point, which is this one, of the curve in the middle. Right, so let's see. Actually, if this module from here to here is 12 meters, the movement in the y direction also needs to be 12 meters. So to the y, I want to assign a times 2 to my y value of the both points here to the y. There we go. So now I have 2 items over there. I want to create the third point here. So it's going to be again, it's going to move by a times 2 in the y direction, and it's going to move in the x direction by a times 2 again. And to the z, I want to assign the same value that we had for the height of the first point. So h divided by 2 goes to z. Right? So I need 2 other points here. I'll go with another point. It's going to have the same y, which was a times 2, that goes to our y. To the x, I want to assign a times 3, so a times 3 goes to my x. And to the z, I want to assign the h again, the height that we had, which was 8 meters. And finally, let's create the last point of the second curve. So I want to go with another point. It's going to have the same y value, which is a times 2. A is the module that I considered for the width. So this goes to my y. A times 4 is going to go to my x. And to the z, I want to go with the same half a height that I assigned to the first and third point here. So let's see how it works. I want to make a curve out of these 5 points again. So I'm going to need a list create because I have more than one item. I have actually 5 items, 0 to 4. It's important that you connect them in order. The order matters here. And from this, I'm going to create a set of NURBS, curve by point. So point and degree, this is what I want to go with. List goes to point, and I want to use the same degree, which is 2, that I used up there. So 2 goes here. So this is the second cross section, and the last cross section is going to be just the first one being copied all the way to the end. Right, so how about I kind of group these items here. These are responsible to create my curve number 2, and if I move the first curve, So I'm gonna go with move or translate. The first curve is gonna be moved in the green axis, which is the y direction, by 8 times 4. So that one, this item here, is the last curve. So the loft of these 3 curves will create the module that we are looking for. So I'm going to group this icon and I'm going to name it as curve number 3. So here's the interesting part. Because I assigned the same code block all over, if I change the value, let's say if I change this to 8, the whole pattern is going to be updated. Same with height. If I change my mind, I want to go with 10 meters high, it's going to be updated all over there. So I'll keep it on 8. And now I have my 3 curves, connect them in order to the list that we have here. The order matters. And list goes to cross sections, and we have our loft here, right? So this project is actually concrete. So this is what you have. You can just thicken the surface. If you right click and go with thicken, either on both sides or only one side, you can thicken the surface maybe by 30 or 40 centimeters, and that goes to thickness, this goes to surface, and you can import this back into Revit. So this project is now done here, but let's say if instead of concrete we actually had a set of lines to make up the structure, instead of what we have here, I would have used ISO lines, right? So how about I group these two? This is my loft surface and we are done with this one. I want to show you some additional option. So we know that this is a surface. So if I go to geometry, surface, and the surface again, if I go here with the lightning sign, which means I can do further modifications on an existing geometry, I can get the ISO lines, right? Let me hide these 3 curves so they're not confusing us. And I want to also hide this list here. Okay, so see what happens when I connect surface to surface. As soon as you do that, it's going to create one line here. You can also assign 0 or 1 to ISO direction. If you assign 0, the line is going to be over there. If you assign 1, it's going to be in the other direction. So let's say if your structure is made up some lines on top of the surface, then you need to assign a set of lines on the 2 directions. So if I go with like sequence to create a set of numbers, let me first show you how parameter works here. If you assign 0 to parameter, the line is going to be at the end or at the beginning of the curve. If I assign 1, actually it's going to be at the end. If I assign 0.5, it's going to be at the middle. So this number is kind of relative to the length. If I put 0.25, it's a quarter of the whole length. So this is what I'm going to do. If I assign 0.1 to the step of the sequence and assign this to my parameter, it's going to create lines every 10% of the whole length. If I go with 0.05, it's going to be every 5%. Then I'm going to need not 10 but 21 items to fill the whole length, right? And you can do it for the other direction too. If I go with 1, for instance, it's going to be like this. So if you need ISO lines on both sides, you can actually group these items, and I can rename it as ISO line, and these are on the X direction. I want to copy and paste this group, and I want to name this as ISO line in the Y direction. We can change this to 1, There we go. So maybe this is how your surface is going to be created, not by a concrete, but by actual elements here. In that case, we need to thicken the curve. So I want to go with thicken. By thickening curve, yes. Actually, I want to go with double of this code block, one for the X direction, one for Y. The thickness, let's say maybe it's about 30 centimeters. So this goes to my thickness. This curve goes here, this one goes here. And the reason it's not working is that I also need to assign a normal to the vector. So let's check the vector. If it's on this direction, probably y is gonna be the vector which is perpendicular to my plane. So I'm gonna go with the y-axis. So let me hide the loft surface. And see how, yeah, this is working perfectly, right? On the other direction, the normal to the plane is actually the x-axis. So I want to assign x to the normal of the other set of lines. So now that also looks good, very good, okay. And now that I have the two sets of lines, these could be maybe made out of wood or something. Let's assume it was not a concrete structure. So now I have a polycurve here, one polycurve over there. I want to extrude as solid. It's going to be closed, and I want to assign distance. Yes, so to the distance I want to assign the same 0.3. I need two of these nodes. This polycurve goes here, this one goes here, and now this is our geometry over there. That looks good. And then we have two sets of solids. In order to combine them, we can go with union. So it's gonna be like this one, which is gonna Boolean union the two solids together. So it's gonna be only one set of solids, right? If I select this, let me hide this one, hide this one. If I select this, yep, now the whole item is selected. And see what happens if I unhide the loft surface. So actually I have like structural elements here, and in between them I have kind of the material which covers, which is going to be probably like either glass or kind of plastic or something, right? So I was assuming here that the structure is not going to be concrete, but it's going to be some kind of maybe modular wood or steel or something, right? So back to here, it's interesting that because everything is connected to each other, now still if I change something, the whole structure is gonna be updated. Maybe I can show you one last thing. So if you want to kind of import this into Revit, I would suggest that import this separately and import the loft surface separately. Maybe it's only 5 centimeters thick. So you can assign two different materials to them. I also want to show you, just hypothetically, let's assume you have an opening somewhere around here, right? So that would also work. Let's say, for instance, we have a cylinder. We have by radius here, but sorry, we have by point and radius, start point, end point, radius. Maybe I can go with this. So I'm assuming there is kind of a cylinder over there, which is gonna be the void. I'm showing you how different solids work together. So I wanna maybe move it over there, so I know that if it's gonna be around there, it's gonna be on the same line that we had here. So I need actually one point here. I'm gonna assign, I think, a times 2. to the y of the point. That's right, it's over there right now. And I want to assign 8 times 1 to the x direction. I'm using the same modules that I had before, so that goes there. So this is my start point. And the end point, I want to copy and paste this point, and to the z I want to assign some large value, like let's say 15. So it's going to be all the way up here. So this goes to my endpoint, right? So this is going to be an opening here. Maybe the diameter is, let's say maybe 1.25. That goes to the radius. So diameter is 2.5. So let's say maybe there is an opening or something here, just to show you, and I'm gonna group this as my void, just to show you how different solids interact with each other in Dynamo. I want to cut this void out of my actual loft structure. So I'm going to group these items as the loft structure. Right? So we have one solid here, and this one is also a solid. This is a solid, so we are going with difference between two solids. I can go with difference all, or I can go with actually difference all is good because the two inputs are both solids. As you see, the output is also solid. So this goes here, this goes here, and I need to hide this and hide this, so I only see the result here. And actually, let me also hide this and hide this to show you how it works. Okay, there we go. So now you see that from this structure, that part is cut. That's what I was trying to do. So it's all good now. If things are getting confusing, hide the nodes that you don't need. For instance, the curves that we had here, I can easily hide them, turn the preview off. Right, and we have also ISO lines here that I can hide. So the void over there, I cut it from the solids, and I also want to cut it from the surface that we have here, which is also a solid. So I want to go with difference. Actually, just to show you how you can cut a solid from a surface, let's assume that I had only a surface here, and I want to cut that void solid, this one. I want to cut it from my surface over there, right? In that case, if I go with difference, this item here, it says subtract the kind of the solid geometry from a surface. So this time, instead of difference all, which is between two solids, we want to go with this icon, which is between a solid and a surface. So in that case, my surface, the loft surface, goes to surface. The void solid, the void here, the cylinder, goes to trimming entity. Now if I hide the void, and the surface is already hidden over there, you see that basically we cut the void from the structure and from the solid, right? So last thing you need to do, you can go with import. Let's see how many items we have here. We have only one item because we made a union solid, and we have 21 items here. So in this case, for this one, I want to go with import by geometries because there are more than one. You see there are 21. And for this one, the loft surface, I want to go with import by geometry because it's only one item. I want to put this on manual, save your file, and this goes here, this goes here. I want to run it. So let's see how it works. Yeah, now they're imported here, and actually this was not a good place to cut that structure. I'm gonna maybe delete this and delete this. Okay, and here to the radius of that cylinder, I don't want to import it at the moment, just want to try this. instead of 1.25, I want to assign only 1 meter. And let's see here, maybe a little bit smaller. I don't want to cut this element, so I want to maybe assign even 0.9 or something, right? So you can work with your numbers, and when you are done, again, I can connect this geometry to import by geometry, this one to import by geometries, and I want to run this, and then we can assign material to them in Revit. So let's run it. So we are done here in Dynamo. I can save and close my Dynamo. Okay, here. Now first let me put this on shaded. Okay, now we have two geometries here. One is the structure and the other one is the loft surface. So if I want to assign material, if we go to object styles, under imported objects, one of these items is the structure, the other one is the loft surface. So let's see if we can just assign some glass or something. Okay, apply. Okay, so that one was the loft surface. And again, this is different than the project that I showed you. I'm just trying to show you that you can make structural elements out of your loft using ISO lines. And to the other one, you can create a new material or assign some wood or something. So this is how the whole thing is going to look like. And I'm going to quickly check it in this elevation. You see it's a little bit lower than the ground level. What I can do, I can assign the two items, and to the base offset, let's see from here to here, let's see if I can get a number. This is 0.3785, so I can assign that to the base offset of the two objects. So two objects are selected. I want to assign point, was this let me check the number again. From this edge to here, this is 0.3785. So 0.3785. So now it's not gonna be, oh, okay. So actually, let me select these one by one. I'm gonna say this number plus 3785. I need to start it with an equation. So base offset is whatever number we have there plus 3785. Okay, that's good. And the other one, actually, I want to select this one, whatever number we have there plus 3785. Apply. There we go. So now it's not going in the ground anymore. And you can go with maximize 3D extents for the levels. Okay, this all looks good.